In this session, we will know about the additional other features of C programming language, namely the variables, constants, and their purpose and service. Before ending the session, we will declare these variables in our C compiler IDE, integrated development environment, right? And then conclude the class. So, yesterday we discussed about floating point numbers. We said there is a typical format or specified format, standard format that is used to represent the floating point numbers. What are floating point numbers? In C, we call them as floating point numbers. In mathematics, we call them as real numbers. There are various formats in which a real number can be stored in compilers, but the most standard one is IEEE 754 format. How does it look like? There are two types of float numbers, single precision and double precision. For each of them, we will see. First, for single precision. How many bits? You can see here 23 plus 8, 31 plus 2, 32 bits are allocated. 32 bit means 2 words. One word is 2 bytes, 32 bits is 4 bytes, and so 2 words are allocated. This is called as single precision. Now, a real number has two parts to it, fractional part and the integer part. But in C, always the floating point number is represented as 1 point fractional part, and in binary the numbers are 0 and 1 only. Unlike in decimal where the numbers are from digits are from 0 to 9, in binary the digits are 2 only, 0 and 1. So always the mantissa is represented 1 with assumed binary point, not decimal point, binary point, and chain of zeros ones is called as mantissa. And the number can be negative or positive. So 1 bit is assigned for the sign position. 0 means positive, 1 means negative. Exponent is 8 bits. So when we write in exponent form, 3 into 10 power 5, that is exponent. Now for that 8 bits are allocated. When we allocate 8 bits, we can actually represent 2 power 8, that is 2 to the power of 256 as the power, but we will not use all of them. Remember, the exponential number has two parts negative. One is for the whole number that is shown in the sign part, and exponent can also be negative. So in order not to lose a bit, what is done in IEEE format is that the exponent is actually biased. Most significant bit, that is 2 power 8th position, that is 2 power 8 minus 1. 2 power. So 8th bit position is used to represent a bias, or what is done is the actual exponent is increased by certain number, that is called as bias. In this case, in single precision case, the bias is 127. So if I have minus 5, 2 to the power of minus 5 or 10 to the power of minus 5, in computers it is 2 power only. This minus 5 is added to 127. 127 minus 5 is 122. So the exponent becomes 122. Now at the time of extracting the number, 127 is, the given number is subtracted from 127, or 127 is subtracted from given number, and the difference is the actual power. So is it clear? What is done is, in single precision, to the actual power 127 is added. This is called as biased exponent. Why is it done? In order not to lose a bit for sign purposes. Every number is in positive, and mantissa is the fractional part. This is how it is done. Now, exponent is 127 is biased. That means whatever is exponent actual value, 127 is added to that. If it is negative, the exponent value will be less than 127. If it is more, it will be more than 127. But there are 8 bits here. We can go up to 256 or 255 for that matter. Right. Now, we'll take double precision now. How many bits are allocated? 64 bits are allocated for double precision now. Of these 64 bits, again, 1 bit is for sign of the number and then exponent. Now, exponent is allocated 11 bits. 1 bit, most significant bit, goes for bias purposes. So, the largest number should be, since it is 11 bits, the last bit position will be 2 power 1023 is the bias here, right? 1023 is the bias. 11 bits are allocated because 11 bits means 2 power 10th position. 2 power 10 is 1024. The largest number is 1023. 2 power 10 minus 1. Like in 2 power 7, it is 128 minus 1. So 11 bits, highest position is 10, starting from 0 in the right. So it will be 2 power 10 minus 1. So the bias here is 1023. What does it mean? Again, the real exponent value, suppose I have again Avogadro's number with the exponent 10 power 23. 23 is added to 1023, that becomes 10,046. When I am extracting number from 1046, 1023 is removed, I get 23. On the other hand, if it is charge of electrons, 10 to the power of minus 19 is there. So from 23, 19 is removed. It becomes 1004, 1005, 1004, sorry, 1004. So 1027, sorry, 1023 from 1023, 1004 is deducted, 19 comes, and that would be regarded as negative, right? So all in all, what we say is that 127 is subtracted. If the answer is negative, then it is negative power, right? We'll see an example now for this, how the number is actually represented. For single precision, we will do it. I have taken an example here, decimal number 76.25. It has two parts. 76 is integer part, 2.25 is the fractional part. First step is to convert this into binary number. So integer part and fractional part are converted separately into binary. Integer part is converted by dividing successively by 2 and getting the residues or reminders and making the binary number. But for fractional part, we multiply with the 2 and go on getting the carry that comes greater than one value. What is comes in the integer part goes into fraction, right? That way we have done. And 76, the binary equivalent of 76 is 101100, and for 0.25 it will be 01. So the actual binary number in the exponential form will be equal to 1.011001 into 2 power 5. Now, in the number, there are only two positions. Decimal number only, two fractions are there. What we have done is, as we said, the IEEE says that there will be 1 in integer part and entire remaining part of the number goes into fractional part or mantissa. So what we have done, this one we have taken here, and 0110, 01100, and again 0 of this will cascade. By how many positions we have shifted? 1, 2, 3, 4, 5. That's why it is 2 power 5. So the binary number is 1.011001 into 2 power 5. Now, the next step is to convert this into IEEE format, how it is represented inside. Of course, we need not know all this, but when we understand how the numbers are stored, we will not commit any mistakes in writing the program and using the variables appropriately, because engineering is more about real numbers than integers. So many computations will be there. We should have familiarity with how numbers are stored, right? So what is now in this part of representation into conversion into IEEE format, the first step to be done is exponent being biased. Exponent value is 5 here, and this is single precision. So what is the bias? 127. 127 plus 5. It is not negative, so it will be 132. 127 plus 5, 132. Now again, we have converted into binary. That gives 1 followed by 4 zeros followed by 100. This is the number in binary. What next? IEEE format, converting it. What number is this 76.5? Is it positive or negative? Positive. So the first sign bit is 0 for positive. Next, exponent should come here. Exponent value is 140,100. It comes here. Next, mantissa, normalized mantissa is to be written. See the wonderful point here. We have written 0110001 here. 0110001. And then what about all these zeros? Remember, IEEE format is 23-bit. So for the remaining empty locations, zeros are filled by the computer for fulfilling the number. Now, is it clear? Let's have a quick review. Convert the decimal number into binary separately for integer and fractional part. For integer part, divide by 2 successively, take the remainder, form the binary number. For fractional part, multiply by 2, take the carry that comes, integer part that comes, form the number. Then bias the exponential. Bias the exponential by adding 127 if it is single precision. If it is double precision, it is 1023. Next, IEEE format, sign bit, exponent bit, and represent all the fractional part after decimal point, binary point. And then supply as many zeros so that the exact number of digits is 23 in the mantissa part. This is how IEEE representation is done. Double precision, that's a self-practice exercise for you. Okay, now we'll go to the next topic. Yesterday we discussed that primary data types are declared in C. The primary data types are char, int, float, and double, a variant of float. We also discussed about the range, the number, and the qualifiers like unsigned, short, long. Yesterday we discussed it, right? We'll extend. Yesterday we also said, in the previous session, we also said that with the primitive data types, tasks cannot be completed. We need additional data types. Those are called as secondary data types. In secondary data, these are higher level, higher order data types, right? Now, first type is derived data type. That means these are derived from preliminary or fundamental or basic data types. This is something like this. Meter is the fundamental unit. Kilometer is derived unit. Gram is fundamental unit. Kilogram is derived unit. Ton is derived unit. Second is fundamental unit. Minutes, hours, days are actually the derived data types. Fine. In C also there are derived data types. We'll understand with the help of a diagram here. Right? Secondary data types can be divided into two broad categories: derived data types and user-defined data types. That means these are the facilities given in the compiler with the help of fundamental data types. On the other hand, the user-defined data types are actually created by the user, making use of both fundamental and derived data types. Right? One is compiler flexibility given. Second one is user exercises his knowledge to represent different kinds of data types. And what are the members here in derived data type? Array, pointer, and function. And in user defined, it is union, structure, and enum. Enum, structures, and unions are the data types. We'll get familiarized quickly with each of them. So data type built on the basic data types are the derived data types, this part. We have arrays, pointers, and functions. What are these actually? How is array declared? See, it is character data type only. Example, name of the array followed by size. This is example for array. So what is an array? It can be integer array, float array, or character array. So basically the fundamental data type is to be attributed, then name of the variable, and then size is to be declared for the array. See, there is no difference between how variables are declared, whether it is secondary data type or derived data type or the basic data type, right? The data type does not change. Accordingly, see the syntax here, data type, name and size additionally comes. How is array given? In a pair of square brackets. We'll take another example. Char star salary is a pointer. So this star symbol indicates that it is a pointer. What is a pointer? We discussed in the introductory session. Pointer is an indicator or representative of the address where a data item is stored, right? This is always represented by star data type star salary. What does this mean is that salary is a location that stores, salary is a location or address that stores a data of type character. We cannot store integer there. Right. Next, another example, int swap. We have already seen this function in the previous session, right? Name of the function followed by variables. This is function. This is how again we see here data type, name followed by variables. Data type star variable name. Data type followed by variable name and the size in case of array respectively. Right. Now we'll go to the next one. User defined data type. Again, same diagram. So user defines to store data items of choice and their combinations, right? So what type of data is stored in user defined data types is not homogeneous or same type of data. It could be a combination also. User wants it. For example, I want to store a composite information pertaining to a student with a roll number, name, father's name, mobile, email ID. You see that each of them are different, right? Each of them belong to different data types and derived data types. Name is an array of character. Roll number is an array of alphanumeric characters. We declare them as char. Right? Mobile number is an integer. Father's name is a character array. Email ID is a character array. All these we would like to store in one single component. This is a combination of it. Here comes the use of the user defined data types. There are three types. The first, the facilitates storing of composite data items. We already discussed about this point. The three types are enumerated data, structures, and union. And how is it given? Enum. This is the data type here. Enum itself is the data type. You can recollect in the data types, in the keywords that we discussed in the previous session, enum was a keyword there. So enum tells it is enumerated number. That means for some variables, they can be given indicative or representative numbers. Always numbering starts from 0 by default. If we don't want it, we can assign numbers, right? Here in the example, it is given here, enum, curl brace, sun, month, when. Now, this is a closed set of three variables, Sunday, Monday, and Tuesday. And Sunday gets number 0, Monday gets number 1, Wednesday gets number 2. Now, we can use these variables for comparison purposes, computation purposes also. Right? Sunday plus 1 becomes Monday. That numerical computation flexibility is given by enumerated data type. We will learn about this more in the programs when we solve them. Right? Struct tag. Now you see structure is defined with a keyword called struct. This was also a keyword. Struct, there will be tag name of the tag, name of the structure that would like, or would like to assign a name or tag to the structure, and an open brace, and data members come here. Data members, it could be one or more. And then we would like to create, when we would like to create an object, an instance of this, we give object name here. So tag name and object name are different. Now, either tag name or object name can be optional. One of them can be optional. We may not give, but a good practice for a good programmer is to give both the names. Object name is used to create instances, right? This is called as defining a structure. When we define, we are telling what are its members, char member, int member, float member. But when we declare this, no memory is allocated. Whereas in case of int, once we declare, memory is allocated, name is assigned. Basic data types and derived data types, memory is allocated once we declare the name. But in the user defined data types, memory is not allocated unless we create an instance of it. We'll have more of this as we deal with these topics in the subsequent chapters. Right, object name and data members. Example. So the next data type is union. Union tag. You see the similarity between struct and union. Same, almost, not almost, the identical declaration is it. But the purpose of structure is different from purpose of union. In a structure, all the members are used. In structure, only one of the members is used. We will see this with an example. For now, remember that structure is a composite arrangement of different combinations of data types. Each one of it participates in some processing. Whereas in union, several members are declared, composite combination of variables are declared, only one of them participates at any point of time. Right? And which one to be used? That the user defines. That depends on the user requirement. Now we go to the next one. After we cover variables, we'll go to the next part. Now, what are variables? Identifiers used to store values in the program. We are already familiarized with variable names, identifiers, how to declare, and what should be the size of the variable name, and how naming convention is to be used, how to avoid confusion to the compiler by giving identical names up to the most significant character positions. Yesterday or in the previous session, we also solved an example, right? Values assigned by the user. To the variables, values are assigned to the users. Value can be altered, reassigned, or updated. We can alter the value. For example, I declare a variable called count. I increase it by 1. I am altering. I am reassigning. I gave count is equal to 0 in the program. Again, in the somewhere in the other part of the program, I use count is equal to 100. Still, it's valid. Updated. Every time in a for loop, we saw updation takes place. 1, 2, 3, updation, right? See, these are user flexibilities. Value stored depends on the data type associated. Every variable should have a data type associated with it. Without it, it is not recognized. Example, car choice. Here, choice is a variable name. Car is a data type, which means that it stores one character data item. Second one, unsigned car flag. This is signed car. First one is signed car, and the second one is unsigned car flag. That means this will run from -128 to +127 characters, and this will run from 0 to 255. Again, whether it is -128 to 127 or 0 to 255, the alphabet's character set recognized is one and the same. Int wages. This is an integer data type. Long int prime. Long int prime. That means it is double the size of the integer, right? 2 words are allocated and its name is prime. Float, rate of interest. This is the variable name. This is the float. See, we have followed all the conventions and rules of following of declaring the variables. Okay. Now we take constants. Sometimes what happens, certain variables or to participate in the program whose value should not change. We will be using the value again and again, again and again. For example, there is a problem which requires logarithms again and again. So I define natural logarithm as NL is equal to 10. Every time I use 10 NL, it will be used again and again. A constant is to be used several times. Once we declare certain variable as a constant, we cannot modify its value. These are part of the main program. They can be above that also, but they are not declared with the hashtag. Yesterday we discussed pi as a constant. That is a symbolic constant. It is not character constant or integer constant. These constants are part of the main program, or they can be global at most, right? They do not close their value and meaning. Naming rules are same as variables and identifiers. It has to start with the lowercase, underscore is permitted, no other special character is permitted, up to 31 or 63 depending on the compiler. All these rules are applicable. Minimum one character is required. They are preceded by word const. Const is a keyword. Again, in the previous session, we discussed about keywords. Const was a keyword. So how do we declare a variable? We'll see an example now. Example, const data type, name of the constant. Variable name, data type, and with the keyword const preceding it. There are 4 types of constants. So if it is character constant, const char x. If it is integer, const int name, roll number. If it is float, const float and salary, something like that, right? Now, there are 4 types of constants. We have already got familiar while discussing the example here. Integer constant, they store integer values only. Floating point constant, they store real numbers. Now, these two put together, these two are dealing with numbers only. So these two are given a collective name called numeric type constants. There are 2 subtypes of numeric constants, integer and floating point. Okay. Character constants, we have seen example previously. And the string constants is another one. String is a collection of characters and those values do not change, right? They cannot be updated or reassigned. An attempt to reassign will throw error in the C programming language. So, stores integer valued numbers. Unsigned constants are appended by u or small u at the end of the number. Suppose I want to declare. We'll see this with the example now. We'll go to our compiler. In this compiler, we'll declare the variables, right? So I'll share the screen here. Fine, here is a screen for me. As usual, I have to declare. I will write the comment here with single line. Today I will use, in this session I use single line only, right? Demonstration of variable declaration. So this is documentation section. Then I write int main. Before int main, I have to write inclusion linking part, hash include. In the symbols less than or greater than, std io.h. This is standard input output library file. It has the definitions for various data types, printf, scanf functions, and other functions that we use. Okay. So main is a function. It has always to be succeeded by a pair of parentheses, and then block starts here, start and end. I'll go to into the car alpha. I have to terminate it. Const or eta. This is how we saw the declaration part. Next, int num1. Again, const int 1. num2. I should not give num1. There will be confusion to the compiler. Next, float tax semicolon const float tax rate semicolon. Lastly, I'll take another example. Int 3. Since it is unsigned, what did we say? We have to use u unsigned here. No, we have not assigned any values. We are seeing only how to declare. Right? Let us compile this program and see whether errors are thrown or not. We are not doing anything, just familiarizing to declare it. Right? Not printing. First of all, I have to save it. Right? Variables underscore const underscore demo.c. Remember, always have to store with C. Now you see color has changed, right? That means I have done everything perfectly. There are no errors. Since nothing is given, it has executed nothing. Output has come. I'll close this window. It doesn't make any sense to me, right? Now, when I have given here tax, simple manipulation, I will do 25.3. Here is that I have given for const int. See, remember, num2 is an integer of the constant value, but I have given real number, right? 1. Let me compile once again. Does it tell me? I will focus on this lower part of the window which shows me errors. It has shown error here. What is that? Expected is equal to, and it is attribute, right? So it says this part is not correct. It requires a little bit of skill. Or the way the compiler throws errors and gives error messages, it needs a little bit of familiarity. For example, you see here error expected equal to, okay, I have missed it, equal to assigning value. Let me do it. Now let me recompute it. I have done, this is syntax mistake. This is typographical mistake, user's mistake. Fine, it has taken. But has it taken 25.3? Because I have declared it as int. Let me see. Let me do one small job. Printf. Again, another function. I'll give double quotes the data type associated with the %d, since it is integer. What is this %d? We'll see in the next session. %d num2 and Do not forget semicolon at the end, otherwise it will not run. Run it. What is output given here? 25 only, right? The output given is 25 only, not 25.23 that I have given, right? You can see here it is 25 and the top line, right? Other message it gives is that process required so and so, execution time so many seconds, and it came out. I need to continue. Close this window. So when I declare it as int, it will not take fractional part. Now on the contrary, what we'll do is on the converse of it, we'll come to float tax rate. We'll give it as is equal to 1. Sorry. Is equal to 1 semicolon. Now what we do here is %L. The variable name we have taken is tax underscore rate. I want to see what is printed, right? Don't get bogged by, don't get confused. It's only on the periphery that we are doing. All these things we are going to cover in the subsequent sessions. For now, what I am trying to cover is how to declare the variables, right? Again, we go with, since I have made modification, run and build. So, oh, there is a mistake here. Not minus sign, it should be is equal to sign. Okay, fine. I am printing tax rate now. I want to see whether 1 is printed, or since it is real number, float number, any other value is printed. Nothing is printed. Nothing is printed. I have to type constant float is equal to 1.0. So this is how we assign values. Fine. So this is how we work. Now we'll go back to our presentation. Come back to our presentation, continue. I hope it is clear and it is simple to understand. Fine. So constant, now we'll have characteristics of this. It stores integer valued numbers only. Unsigned constants are appended by u or u at the end. We will use them in the real programs, right? Decimal number is radix 10. Number found by combination of zeros up to 9. First digit must be non-zero for a 2 or more digit number. For example, suppose I want to store 9. I have to store it as 9. I cannot give 0, 9. All zeros will be discarded by the compiler. So, if you want a number to be represented, 009 will be reframed as 9 by the compiler, right? Next, const int rank is 10. I cannot write 010. It will be taken as 10 only. If it is octal number, radix 8, then the numbers will be found with a combination of 0 to 7. So in the decimal number system, the digits run from 0 to 9, 10 symbols. In octal, 0 to 7. What is the similarity here? In decimal number system, largest digit is 9, 10 minus 1. In octal number system, where the base is 8, the largest digit is 7. So the number found is between 0s and 7. Now, octal number, I can declare octal numbers also in the C programming language, but there is a condition. It has to be preceded by 0. First digit must be 0. Example, const int position is equal to 050. When this 050 is given, when this 0 is given, compiler will interpret it as octal number and it will retain the 0. Right? Next. Hexadecimal number. That is, the base is 16 now. So largest digit will be 15, but it will not be represented as 15. It will be represented as F. So the symbols in hexadecimal number are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 digits. and then A, B, C, D, E, F, right? F in hexadecimal is 15 in decimal, right? Again, how to represent them? The first two characters have to be 0x. See here, first two digits must be 0 lowercase x or uppercase x. Example, const int score 0x5. Now, when compiler sees 0x, this number will be interpreted as hexadecimal and the arithmetic or operations will be performed in on hexadecimal numbers. When the compiler sees 0, the operations will be performed on octal numbers. When nothing is seen, first digit is seen, it will be interpreted as 1. So that's what we say when we declare integer variables, we have to take care that if it is decimal number, if we are clear that we are working in decimal number only, then the first digit has to be non-zero. If you declare x is equal to 09, that would be interpreted as octal number. It will not say number is wrong. Compiler will not say it is error. Compiler has his own understanding, its own understanding, right? If you give most significant non-zero digit here, it is decimal. Most significant decimal digit 0, it is octal. Most significant two digits 0 and x, it is hexadecimal. So take care while declaring variables. If you want to perform in octal, make sure that number is preceded by 0. Don't assume. Next, floating point constants. They are similar to their corresponding floating point numbers. The only a base 10 number that contains decimal point or exponent are both. It has both the parts. For example, 1 point. 1 point. In the previous program, we typed it as 1. If we put 1 point, it will be treated as real number only. You need not put zeros after decimal number. It will be interpreted by compiler as number only, for real number only. 0.5, 2.78, 63e minus 3. This is also 0.63e minus 3 is also another way of representation. Range is much higher than integer constants, but not exact as integers. See, as we saw in the previous representation in the discussion about IEEE number format, 23-bit positions are taken or 52-bit positions are taken for single and double precision, but need not be exact number. For example, it may show as 2 as the number when I print a value, but it could be internally 1.999999. So 1 by 3 plus 1 by 3, 1 by 3. 1 by 3 plus 1 by 3 plus 1 by 3 is 3 by 3 is equal to 1 for me. But for the computer, it will be 0.999999. But rounding takes place and 1 is represented. We should be very particular about this knowledge when we are doing precision arithmetic, where the correctness of answer is very essential. We should keep in mind what is happening in the computer. 0.0 is valid floating point constant, normally represented by double precision quantity in C. Therefore, it occupies 2 words or 8 bytes, right? If the value is appended by F, it represents single precision of float and hence occupies only 4 bytes. So when I write, see, by default, if I give const float, it is double precision, right? Then I have to use another argument. That's why I didn't get output there. I will show it elsewhere in the subsequent programs. If the value is appended by F, suppose I require I declare const float x is equal to 2.3 F, it is single precision. If I don't put F, it is double precision. Accordingly, the way I take the methodology I should use to take out the output changes in the print statements. Almost all variants of C languages permit at least 6 significant figures, minimum 6. That means if I write 2.3 and if I give value 2.3 and print its output, I will not get 2.3, I will get 2.3 followed by 5 zeros, 6 decimal positions, right? 3.2 is represented as 3.2 4 zeros. Now, why not 5 zeros here? Point is also a place, right? 1, 2, 3, 4, 5, 6 is there, right? This can also be written as 0.32 E1. That is 0.32 into 10 power 1. Fine. Lastly, we'll talk about character and string constants and conclude this session. A single character enclosed in single quotes, opening single quote and closing single quote. For example, the and itself is shown here, but and is not single character, 3 characters here. How does C deal with it? We'll see in a while. Have integer values determined by the character set. A is a number for the computer. It has certain ASCII value, right? Value may vary from one computer to another computer. As we said, ASCII code based computers give one value. EBCDIC mainframe computers give another value. It depends on the character set, it depends on the architecture, it depends on the operating system, it depends on the compiler also, right? We'll not confuse more. We'll assume here that we are using ASCII. By default, we are using ASCII because all our syllabuses are framed on ASCII character set only. Character constants are independent of character set. This makes a C program independent of any particular character set. That means, what does it mean? We talked about portability in C. When we declare constant variables, what is constant variable in ASCII computer need not be the same elsewhere also. By looking at the compiler, by looking at the code, appropriately assigns constant values. So they are not bound to one single character set, right? Most computers use ASCII character set, as we said already. Each character is encoded with a unique 7-bit combination. ASCII uses 7-bit combination, right? What is a string? String is a collection of characters we saw in one of the earlier examples, right? String is, it's a collection of characters, but the difference between character and string is that character is enclosed in single quotes, whereas string is enclosed in double quotes, as you can see here. And we can perform arithmetic operations and logical operations, comparison operations between two character variables, but we cannot do that with string, right? Every string is terminated by a null string. For any string to be recognized, the last string has to be \0. Recollect, we used this backslash in the previous session. Backslash is a special character, escape character. Backslash always succeeded by another character becomes a single character for operational purposes. In this case, \0 is an indicator of a new line. When a string is declared by me in the programming language, compiler automatically appends it with this null string so that the string is accessible. In the absence of this null string, we cannot access the string, we cannot perform any operation, right? We have already seen declaration of variables. Quickly we'll go through that. Declaration associates a group of variables with a specific data type. We have seen int x, car, like that. That is called as declaration. All variables must be declared before they can be used. It is something like if you want to prepare food, get the ingredients on your table readily so that you can use them. You cannot forget any of them. Of course, in case of food, if you forget, you go back and get it. Similarly, here also, if you don't declare a variable that is used by you, go back to the beginning of the program, declare the variable and come back to the point where you are using it. Declaration consists of data type followed by one or more variables. I can declare multiple variables on the same line by separating them with comma, right? And each statement we have already seen, each statement has to be separated by terminated by a colon. Example, syntax here, data type, variable 1, variable 2, and so on. The last character will be semicolon. Example, int x1. Another example, float y1, y2, y3. Here I have declared only one variable. Here I have declared 3 variables of the same type. It means that this statement means that the programmer wants to use 3 variables of the float type, y1, y2, y3. Memory is allocated. Char p comma, name of 20. Now you see there is a character variable and a string. How is string declared? Name of 20. So in this program, in this example, the programmer wants to tell that he uses a string of 20 size and a character variable of single character, right? Short S1 is equal to 500. Now, what is the difference between previous statements and this one? Here I am also assigning a value. This is not called as assignment. This is called as initialization. When I declare the variable and assign give value also, that is called as initialization, not declare assignment. Assignment is done in the processing area, right? Initial values can be assigned at the time of declaration of the variables. So we already discussed statements cause computer to carry out some action. For example, int x is a statement. Every statement is to be terminated by a semicolon. And three types of statements are there. Simple statements or expression statements. Expression followed by a semicolon. Compound statements, several individual statements. For example, main is a compound statement. Main is a function which is a collection of compound statements. We have written several statements, open with curly brace, close with curly brace, right? Not that only functions use curly braces. Everywhere where you want a block of program to be executed, that can be put in a pair of curly brace. So the programmer is at liberty to use pair of curly brace everywhere in the program. The only care to be taken is number of opening curly braces matches with number closing. There should not be any ambiguity there. Control statements. Use it to create special program features like logical tests, loops, branches. Control statements are not terminated by semicolon. We'll see in an example when we do a program in the next subsequent second or third session, right? We'll go with programs. Now, symbolic constants are, we already discussed, we have used in one example, hash depend phi is equal to 3.14. It's a name that substitutes a sequence of characters. So the difference between other variables and other constants and symbolic constants is that other constants can be operated with all logical, arithmetic, and relational operations. But symbolic constants actually are used to substitute, replace the occurrence of one term with another. For example, in a program, wherever pi appears, pi will be replaced by 3.14. That 3.14, is it a numerical value or a string value, depends on where it is inserted, right? The characters may represent a numeric or character or string constant. Each occurrence of the symbolic constant in a program is replaced by its corresponding character constant. So there are 3 points, 3 parts. Hash define, the name that I want to use, the name I want this name to be replaced. Usually defined at the beginning of the program. These are called as preprocessor. What is the syntax? You can see here, hash define, symbolic name, sequence of characters to replace. Hash define is used here. All the preprocessors are written above the main program. Example, hash define pi 3.14. Suppose I write pi in program. Repeat, right? Wherever pi occurs in the program, it will be replaced by 3.14. And if the associates of this pi happen to be numbers, then 3.14 will be number. For example, area of square is equal to pi r square. Suppose I write pi into r into r. This pi will be replaced by 3.14. Since r is a number, 3.14 will also be a number, right? If I write in a print statement, the value of pi is a constant, with pi being this way written, that pi will be replaced by 3.14. The value of 3.14 is a constant. Now 3.14 has become string in that string actually. So That we need to remember very clearly. Don't expect it to be a mathematical expression. It is a literal substitution. Wherever you find this, replace with this one. The operation performed depends on the context in the program. Hash define color red. Now, see here, wherever the word color appears, it will be replaced with red. Now you see a peculiar point, an important point to note is that I have used PI capital, color as capital. So the convention is that symbolic constants are defined with capital letters, but it is not the case with what I want to replace it with. Symbolic constants are not terminated by semicolon either. So control statements, symbolic constants, definitions of functions are not terminated by semicolon. These are syntax errors. Okay. So this is how we have done. What we have done is, okay, declare a character we have already done. Integer, float we have already done. We'll visit that. Declare a character constant we have done. Float constant we have done. Short integer constant we have done. Declare a string constant. This we have not done. Right? Chalo. Declare a string constant. Next, demonstrate the declaration, expression, compound control statements we have done in the program. Now, we'll go back to the program part. That is our compiler. We'll see once again here. Fine. So I'll do one more thing here. I'll come up. Hash define. Hash define. See the ease of use. When I write hash, it is showing what is to be inserted here, right? I can select it and do it, right? Hash define name by Desai. Now, wherever name appears, it will be replaced by Desai. Right? I'll write here. My name is, I'll make this as a comment. I don't want this printout now. My name is, come on, as I have typed there. Rather than doing this, we'll put this way. Fine. Car alpha, come on. Name one. Of 10. Sorry. Now I can type name is equal to name. What happens is that whatever was this name, this will be assigned to this one. That means name, I have written name here. Name is equal to N-A-M-E. What happens here is that wherever this name is found, capital name is found, it will be replaced by this sign. That's how it happens. So this is what is in this session. We'll conclude this session. Before concluding, quick recap. What we have done in this session is we have known about, or we are familiar with variables, constants, string constants, floating constants, and character constants, as well as how to declare variables. We have familiarized ourselves. How to assign values we have seen, and then the symbolic constants also we have discussed. About the statements, we understand that every statement is to be terminated by semicolon, and statement makes the execution part of it. Some action is taken through a statement. And also statements can be of three types: expression, compound, and control. Control statements are never terminated by a semicolon. So we'll stop here and continue in the next session. Thank you. We'll meet again.